Jai Gurudev. Today we are going to see the equations of motion in 11th standard. See, here in equation of motion there is a two type of derivation is there. One is analytical method, another one is graphical method. First we focus only derivation by analytical method. In the case of analytical method, see how to derive the equation of motion. Already familiar the three equations of motion. What are that? V equal to u plus at, s equal to ut plus half at square, v square minus u square equal to 2as. So anyway, how to derive that equation? See that we know that acceleration a equal to change in velocity by time taken, or a equal to final velocity minus initial velocity by time taken, or we can write a equal to v minus u by t. Can rearrange the equation, you can get v equal to u plus at. In the same way, second equation, distance covered in time t by moving body. Let we consider initial velocity of the object is u, final velocity of the object is v, acceleration a, time equal to t, distance covered in given time is s. So we know the formula. What is that? Average velocity equal to initial velocity plus final velocity by 2, or we can write average velocity equal to u plus v by 2. We know that distance covered in a given time equal to average velocity into time. Then you can substitute the value outside s equal to u plus v by 2 into t. But here only one thing, you have to substitute the value of v. What is v? Already familiar in first equation, v equal to u plus at. Just you substitute the value of v, and then you can derive that. What is that? S equal to u plus at by 2 into t. Then you rearrange the equation, you will get s equal to ut plus half at square. This is the way you can derive the second equation. Third equation, it's also very simple. This equation of motion is derived by substituting the value of t from the first equation. So you know the first equation, v equal to u plus at. From that one, we derive the equation of the t equal to v minus u by a. Now we can substitute this one. Already familiar, s equal to ut plus half at square. In the equation, t equal to v minus u by a. Substitute and rearrange the equation, you will get v square equal to v square minus 2as. And next one, derivation by graphical method. You can see the graph, the same thing. Here you see the graph, time takes in x-axis, velocity takes in y-axis. A, B is the body move from A to B in a t second. So O to A represents at u, initial velocity, that is 0. After the point A, they started to move. So that is a velocity. Clear. You see what's the final velocity? That is v. That is from C to B is a final velocity. From the graph you can see BC. What is BC? BC equal to BD BD plus DC, where BD plus what's the DC is nothing but OA. Am I right? Substituting the value of BC. BC equal to what is that? You know, BC equal to V, final velocity, and OA is the initial velocity U. So we can write what is it? V equal to BD plus U, or BD equal to V minus U. Straight away here we can use the formula, what is it? Acceleration equal to change in velocity by time taken. So we can write A equal to BD by AD, or we can write BD by OC. Then you can substitute what is BD, V minus U, and OC what is it? T. So finally you can get V minus U equal to AT, or V equal to U plus AT. In the same way, second equation, same graph. Here time takes in x-axis, velocity takes in y-axis, same graph. But here we are going to see what is the distance. S is nothing but area of trapezium. That is what is a trapezium? O A B C is a trapezium. Am I right? But in this case, the trapezium looks like there's a two parties there. Inside the trapezium, there's a two parties there. One is triangle, another one is a rectangle. See, the area of the trapezium is nothing but area of the sum of the rectangle and triangle. So we can write what is the area for rectangle, breadth into height. So we can write OA into OC plus what is the area of the triangle of BH. So half into AD into BD. Then you substitute the value BD equal to V minus U equal to AT, or finally you can get S equal to UT plus half AT square. Right? Very simple. The same way, third equation, very simple. The same graph, time graph takes x-axis, velocity takes in y-axis. But here also same thing. What is the distance? Distance is equal to area of trapezium OABC. But here I am going to use what is the area of trapezium formula, 1 by 2 into sum of the parallel sides into height. You know that. One more time I tell you, the area of the trapezium is equal to 1 by 2 into sum of the parallel sides into height. So what are the parallel sides? OA and BC are the parallel sides. Just add OA plus BC into height. What is it? OC by 2. Then you can substitute U plus V. I mean OA is U, BC is V, OC is T, U plus V into T by 2. Here T could already be derived from the first equation, T equal to V minus U by A. Substitute, then rearrange the equation, you will get outside V square minus U square equal to 2AS. This is the way you can derive the equation by graphical method. Clear? So based on this equation, I give a worksheet. You can try to solve these questions. If you solve this question, definitely you will get full idea about the equation of motion and problem area. Maximum, if you solve means it will be very easy for NEET and JEE preparation. See, worksheet is here. Just I posted here. Clear. I can use, try to solve. Okay, thank you. Next video we will see the next topic. Thank you.